So here I have an object, little arrow here, which is, I produce that by having these light rays converging at one point. Right, so here's my object, and the light rays coming out of the object, they are diverging because every object shoots out light, so their light rays are always diverging from an object, and they just go out, right? I'm going to put a converging lens in the way of those light rays, which we already know that is going to make an image of that object. So the light rays are coming in, they hit the converging object, the converging lens, they converge at one point. If the object is far away from this lens, the light rays are going to come somewhat parallel, right? If I was far away, even further than this distance, then they will even look more parallel, which tells you that the point where this object is going to be imaged is going to be a point that for this setup is going to be close to the focal length of this. Because if this object was at infinity, the light rays will be coming in parallel, and we know what the converging lens does to parallel light rays. It focuses them at one point, which is the focal point, right? If the object is far, but not exactly at infinity, it's still focused somewhere near the focal point, not exactly at the focal point, okay? Now notice what happens when I start moving the lens. What are you noticing about the light rays on the other side? The ones that come out from here. Notice how steeply they're coming in at the focal point. And the angle is getting smaller. They were like this, it's getting smaller, right? We'll keep going. Oops. It's got a magnet there, so that makes it hard to move smoothly. And right about here, the light rays turn parallel. They're not coming in parallel as you saw before. Light rays diverge from an object, but they're hitting the lens and they're turning parallel. So that means that, as you saw, the image of the object of this was, we just discussed that, will be inverted and somewhere there. As we move the converging lens closer and closer to the object, the light rays that were being focused tightly, they start to be less tight, less tight, less tight, until at this point, which is the point where the object is at the focal point of the lens, the light rays become parallel, which means that the image of this object is being formed really far away. If they were exactly parallel, the image, you would say that is formed at infinity, right? So all the way from there to here, the image has been on this side of the lens, and if you do your ray tracing thing, you will find the image inverted. At this point, things start to change. Once you pass that point, notice what happens to the light rays. Now they're starting to diverge. The converging lens, the light rays are diverging from the object. They hit the converging lens, but the converging lens is no longer, it's not strong enough to make those light rays that are diverging from the object, it's not strong enough to make them converge. Okay? So since it's not strong enough, it kind of bends them, but not enough. So they're still diverging on the other side. But now, if you're an observer on this side, looking at the light rays coming from that lens, you would see that they seem to be converging on the other side of the lens. So for the observer here, the image of the object will be somewhere there, and notice that it could be a lot bigger than the object itself. If I get even closer, notice the steep angle at which those light rays seem to be would converge. So at the point where they converge, say at the tip of the ruler that I'm holding, that will be where the tip of the arrow, the little arrow here that I have, that would be where the tip of that arrow would look. So holding a converging lens, this one, very close to an object, gives you a magnified image of the object. Right? This thing is called a magnifying glass. It's just a converging lens, that's it. You put something around it to hold it in your hand, but that's all there is to it. Okay? So the image, notice that it's upright. When you're that close, the image is upright, and it's actually bigger than the object. If you start bringing your magnifying glass away from it, the light rays turn parallel, so the image is not back there, and it's maybe at infinity, you could say. And as you pass the distance, where the distance is where you pass the distance between the lens and the object that is it's bigger than the focal length, then the light rays start to converge on that side, as you can see already. So now the object the image is going to be real because the light rays are converging, physically converging at some point, and the image is going to be inverted. Notice that if the tip of the object is above the optical axis over here, if it's above the optical axis, then the tip is going to be on this side, it's going to be below the optical axis. So it's an inverted image. So that's what you have for a converging lens. For a diverging lens, things are a little bit less interesting. So the light rays diverging from the object, they hit the diverging lens, and now they spread out even more. Right? They were already spreading out of the object, they hit the lens and they spread even more. Okay? So that tells you that if you were to take those light rays and trace them back, because for an observer here, those light rays seem to be coming from some common point. So if you were to trace those light rays, over here, seems to be intersecting over there. The other one I can't see very well. There. So those light rays seem to be intersecting at this point, right? That's where the image of the object is going to be. And as you move it closer and closer, that doesn't seem to change much. The light rays are still diverging. The image of the object still seems to be forming in front of the object, and that never seems to change. Oops. That just doesn't change at all.